Hi guys, welcome to my video. This is the GD&T video 4. This is all about working out positional tolerances. If you've not watched the first 3 videos, it's probably best to watch them first. Okay, so this is what's in this video, working out positional tolerances. There's certain scenarios that keep coming up all the time, and we're going to look at these certain scenarios to work out the positional tolerances. Okay, so I think the best way of working out the positional tolerance, or to understand what you're trying to do, is to draw out what you're trying to show, because the visual aids what you're trying to do, and it makes it a lot easier. So the important thing here is there's different ways of doing this, but what we're doing here is we're assuming that we've got a positional tolerance on one item, a positional tolerance on another item, and we're trying to work out here what bolt will fit through the 2 clearance holes in this particular scenario. So the positional tolerance on one component, on one plate, is this circle, and we're drawing the hole at the extreme of the circle in this direction, in like the Y direction. And again, we're doing the same on the other plate. So the other plate's got a positional tolerance here, and we're drawing the circle on the extreme. So we've got 2 positional tolerances. One is comma 2, one is comma 1. So this is comma 2, this is comma 1. So this has been drawn at that size. So if you've got a CAD package, you can draw this circle 0,1. You can draw this circle 0,2. You can draw this hole size here on this point, and you can draw this hole size here on this point, and you can work out what bolt will go through the hole. So this is a very good way of seeing what the problem is and what will work. So here what's happening is we're working out the smallest hole size, and we're putting the holes at their extremes of positional tolerance to work out the worst case scenario, and that's how the positional tolerance works. Okay, so the couple of scenarios that usually come up are a clearance hole and a clearance hole and a bolt. That's quite a normal scenario. It's probably the easiest one to work out. We've got a clearance hole and a tapped hole, and a clearance hole and an interference dowel hole. So they're the ones that come up sort of all the time, and they're the ones we're going to look at. So the positional tolerance is worked out using the minimum hole size and the largest bolt size, so the max material condition. What is required is the minimum clearance between both, and that's what we're after. So we're going to look at a scenario of a clearance hole of 11mm plus minus 0,25 and a clearance hole of the same 11 plus minus 0,25, and we're going to assume a bolt size. The maximum size of the bolt is usually actual stated size. It's actually a few microns less normally, but on working out sort of the worst case scenario, I would use the actual size itself, so 10mm in this case. So the way it works in this particular scenario, all you need to do is work out the clearance between the 2. So the clearance is 10,75, so the clearance hole at its smallest size minus the bolt at its maximum size of 10 gives us a clearance of diameter 0,75. So we can put a positional tolerance on both parts of 0,75, and the bolt will find its best centre between the holes. So coming back to this scenario, that's what we're going to draw and we're going to work out, but we're going to assume the same positional tolerance. So here's one component, this top plate. Here's another component, the bottom plate. And we've got a clearance hole here, and we've got a clearance hole here with the bolt going through. And that's what this is showing. So if we come to NX, we can just do a new part. And all I'm going to do here is a sketch. So we're going to prove that the positional tolerance works with the way I've just calculated. So this is the 0,75 positional tolerance. So that's my positional tolerance circle. The way positional tolerance works, because we've got theoretically exact dimensions, if the positional tolerance works on one hole, it works on all the holes. So we only need to work it out on one hole. Right, so that's our, let's just make sure that's reading right. So press Alt and 3, for example. Right, that's just not rounding now, so we've got 0.75. And I'm going to draw the hole, one hole at this extreme and one hole at this extreme. I'm going to see the bolt size that goes through. I think this was 10.75. So on that position, we've got the clearance hole of 10.75. Let's draw that. Let's just let's edit that so we can see. That's in green. Now we're going to draw a 0.75 at the other extreme at this position. Let's just make sure it's not rounding that so we can see. There we go. And the size of this one wants to match this one. So it was 10.75. So what we've got here is we've given a positional tolerance of 0.75 and we're producing one hole on the extreme of the positional tolerance here, which is this hole, and we're producing on the other plate the extreme of the positional tolerance at this location. So this is your worst case scenario, and what we need to make sure is the bolt can go through the centre. So the bolt would have to ensure it goes through this hole here and this hole here. That's the maximum size of the bolt. Right, so let's draw the hole. Let's just draw a hole in somewhere. So this is going to be the bolt hole. So because we're working in the y-axis, we can put the centre of this circle on the y-axis. Like so. And now what I need to do is make sure this circle touches this location and it touches this location, and that will give us the size of the bolt. There you go. So that is your bolt size. Let me just change the colour. Let's go for red, I think. Let's go for orange. Right, so you can see there, that is the size of the bolt. So if we've got a 0.75 positional tolerance on one plate, a 0.75 positional tolerance on the other plate, we produce one hole to the extreme and the other hole to the extreme. This is the size of the bolt that can go through. And because positional tolerance are theoretically exact, if it works on this scenario, it works on all holes. So let's see what size this particular hole is. So let's put the diameter in. Let's make it a reference. Right, let's just make sure it's not rounding. It's Alt 4. Yeah, so it's not rounding. So that's basically what we said. So we've got diameter 10. So a 10mm bolt will go through this scenario. So we've just proven that works. Okay, so we've proven that this 0.75 works, and this method is sound. Best way is to always draw it out if you're not sure though, because you can't go wrong then. Okay, so the next scenario, we've got a clearance hole of diameter 11 plus minus 0.25 and an M10 threaded hole in the next component. So we've got component 1 here, which is the plate, and component 2, which is a plate with a threaded hole in. So this is a clearance hole and this is a threaded hole. So the way this works, It's a slightly different scenario because here the bolt can't find its best centre through two holes. The bottom component is actually driving the position of where the bolt's going to be. So in this case, you've only got half the allowable positional tolerance. So if we work out the clearance, 10,75 minus 10, it's the same as before, 0,75. But in this case, because one component's driving the position, we have to half the positional tolerance. And we have to use half the positional tolerance on this component and half this positional tolerance on this component. So the allowable positional tolerance on both parts is now 0,375. The important thing here, though, is we don't have to split this 0,75 evenly. As long as the positional tolerance on this component and this component adds up to the 0.75, then it will work fine. So that's the same as an interference dowel hole on one side. So in this case, the interference dowel hole would be this end and the clearance for the dowel would be this end. But it's the same scenario. You've only got half the positional tolerance because the interference dowel is driving the position of the top plate. So here, the important thing is we just need to divide it by 2. And we're going to work that scenario out now. Okay, so let's do a new part. Do a new sketch. Right, so let's draw a circle this time. Draw a circle this time, but this time we're going to go for the 0.375. So this will be 0.375. Let's just divide it by 2. So that's the positional tolerance on both components. So what we'll do, we'll draw on the top one. We're going to draw the clearance hole. So that's 10.75. And on the bottom one, we're going to draw the threaded hole. And the threaded hole has to be inside this circle. So I'm going to draw the threaded hole on the bottom. And the threaded hole is 10 mil. Worst case scenario. Let's just change the colour of that. So if you look now, this is our clearance hole and this is our threaded hole. So this scenario is a little bit easier to draw, and if you look, this one is inside the blue one, and that's the most important thing here. Let's just prove that. So here I type the size of 10 millimeters in. Let's make that a reference. Let's go for Alt 4. Right, so that's a reference now, so we should be able to move that. There we go. And now what I'm going to do now, you can see there, the size is changing, 7,9, whatever, depending on where I move this circle. If I make this tangent now, this will give us the worst case scenario. So tangency between there and there, down to 10. So that's just proven now that the clearance hole or the bolt will go through the clearance hole at worst case scenario. So that scenario does work. Okay, so that's where this positional tolerance comes from, and it's quite easy to work out. You can look at a part very quickly and know whether something's going to fit very quickly just using this method. So best practice. It could be more cost effective to use 2 clearance holes rather than a threaded hole and a clearance hole if possible. So we've just proven that we've got twice the positional tolerance if we use a through hole and a through hole than a through hole and a threaded hole. So it can be a lot cheaper with a through hole and a through hole for manufacture. it can be more difficult to accurately position the threaded hole and inspect the position of the threaded hole rather than a clearance hole and a clearance hole. Also, the max material condition can be added to the clearance hole to give extra positional tolerance if the hole is not manufactured to minimum size. And the max material condition should not be used on threaded holes because the threaded hole drives the position. It's not the size that makes the difference. So don't use max material on threaded holes. So in this case, what you want to do, you don't want to split the positional tolerance evenly normally. You probably want to give more positional tolerance to the threaded hole rather than the clearance hole, because the clearance hole, the actual size can add more positional tolerance using max material. So it's usually better to split and give more positional tolerance to the threaded hole than the clearance hole normally. Okay, thanks for watching my video. Don't forget to watch the next one. Thanks guys, bye.